Previously on CSIS 2470.
And north again, and beautiful. Okay, now you'll remember that he still has this problem, right? And keep going forever. Well, we got to block him in his world. So let's take care of that. And I want you to stop and think for a minute, how would you solve that problem, right? It's a pretty simple thing, but let's think about it for a minute, and then I'm going to draw a little diagram. Now remember, the robot was born here, and from the robot's perspective, that's the top of his world, and this is the left of his world. And so when he's in here, let's get a different color to represent the robot. When the robot is in here, by default, his top position is 0 and his left position is 0. That's where he lives. Well, the first thing we did is we set his top position to -100, right? So that's why he's always here when we start the game up. We move him to the right by manipulating his left position. Well, his left is 0. Even when he's moving up this here, his left stays at 0. What we're going to do if we move him this way, though, is we're moving him 100 pixels away from his 0 point, which is there, and then 200 pixels away, and then 3, and then 4, and so forth. Well, what we want to check for is if his left position is here, and he's trying to move east, well, then we want to stop it. Well, that position happens to be 900, right? And you can count that, okay? This position for the top, well, when we move him up, he's right now -100. His top is -100 from here. That would be 2, 3, 4, 5, 6, 7, 8, 9, and 10, or 1,000. So if his top position is -1,000 and he's trying to move north, we block him. And if he has left at 0 and he's trying to move west, we block him. And if he has a top of -100 and he's trying to move south, we block him. So that's how we're going to solve this, and it's very easy. We'll just check for it in our code. Super easy. Barely an inconvenience. Some of you will find that hilarious. So let's take a look at here in the move. When we are pointing north, that's the direction we want to move, is north, because we are pointing north. Then we're going to decrement by 100. However, if we're already at -1,000, we just want to get out of there, right? So that's easy enough. We can just say if robot top is equal to -1,000, then just return out of the function. That's it. We don't have to return any particular value. We just get out of there, right? We can do the same thing on the south, except for looking for -100. If the top is -100, then we just get out of there if they're trying to go south. If they're trying to go east, then we're going to look at the left value. And if the left value happens to be 900, then we return out of there. And then the last one, of course, the same idea here for west. If the value happens to be 0 and I'm trying to go west, it shouldn't let me. And that's it. The robot should now be confined to his world. And let's see if we're right. Refresh, open the console, check for errors. Okay, move, 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 move. And I'm going to get to the top and I'm going to click it again and he doesn't go. Let's turn east, move, move, move. And one more click and he stays. Let's turn south and click, 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 and he's staying. Let's turn west, and he's staying. And this is true everywhere. If I go north, move up a couple, turn east, try it over there, it won't work. So looks like he's stuck in his world. All right, last little quick thing I want to fix with his motion here is look how choppy he is, right? He's jumping, and then when he turns, he kind of just jumps there. Well, that's easy. We just put a transition on him, right? And I have that already here. I had it commented out just so I could show you how simple it is to do that. Now in line 96, we're putting a transition on everything. And we refresh, and now when he moves, it's nice and smooth. Turn east, it rotates, south, west. Now we just have to teach him how to eat. So we got to put a donut on the field somewhere, right? So how are we going to do that? Well, let's get rid of this. We don't need that. I mean, we're pretty much done with operating the robot, I think. Let's get rid of that. So how do we place the food? Well, really all we need to do when we build the world is just pick a random spot, right? So we can do a random. Let's let rand equal math.ceil math.random times 100. And just a quick refresher again, this is from 1430, but as a reminder, the ceiling function takes any number and rounds it up to the nearest whole number. So 1.00009 will round up to 2. And then math.random gives a random number between 0 and 1, so a decimal number. So what we're doing is we're taking some random number like 0.03 and then we're multiplying it by 100, and then now we have a whole number and a fraction somewhere between 0 and 100, or 0 and 99 is what it'll end up being. Then we ceiling it, so it'll round it up to the nearest next number, which gives us a range of 1 through 100. Well, if we are inside of our loop, so this is now a random number between 1 and 100. Inside of our loop here, all we got to do is just say, hey, if the random number happens to match the iteration of the loop we're on, let's just put a donut there, right? So let's make this a little bit easier to work with. Oops, let me fix that. What just happened? Sorry about this, folks. There we go. And the computer's got a mind of its own. Okay, what I was trying to do here is put each piece of this on its own separate line here. So put the paragraph part here and the div, closing div down below, like this, right? So now, this is still the same effect, right? Let's just run it and make sure we didn't break anything. But it still moves, it rotates, it moves the right way, and so forth. But now I've got it where I can work with this a little better. So what we want to do, let's just do a ternary operator right here, right? So we're going to do ternary operator, and the condition we're checking for is if rand is equal to I. If it is, then we're going to put the donut here. So that's image source equals image robot food.png is, I believe, what I called it. And if it's not that, then we just put the plus sign there. Now I think we need to style this image. I think I have a class for it, but let's refresh. And there's the donut, right? So let's quickly give that a class of food, I believe is what I called it in my CSS. And there you go. It's the right size. Now every time I refresh, it should just randomly put it in a different spot, right? So far, so good. So what?
So far, so good. So what?
Now we're going to move the robot up, 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 turn to the right, move, move. And when I hit eat, well, nothing happens right now. You ate the donut. I want to make the donut disappear. And then I want to make the robot do like a cartwheel and end up centered in the page. The problem is we don't want it to do that unless he's actually on top of the donut. Okay, well, how do we know he's on top of the donut? That's a little trickier than you might think. Okay, we need to keep track of where the donut is. In other words, right now the donut is on row 7, column 3. And then we need to keep track of where the robot is. Okay, we'll keep track of where the robot is. That's easy. Okay, let's just go up here and we'll have a robot row and a robot column. And then when we initialize the robot, we'll just say robot row equals 10, right? He starts at the bottom, that's the 10th row. And robot column is 1. He starts in the first row. This, by the way, is why we used 1 and 100. The thing we're about to do is why we use 1 through 100 rather than 0 through 99. Okay, so now I can tell where the robot is just every time I move. That's easy enough, right? If we just go down here to our move function right here. So right here on north, if I move north, I'm subtracting 1 row, right? So I can just do robot row minus minus. And then if I'm moving left, or moving to the right, I should say, moving east, then that's going to change the column, robot column, and that's going to increment the column, right? Because the columns start on the left at 1 and they work their way up to 10. And then if I'm moving south, robot row again, and minus minus, sorry, plus plus, right? Because they start at the top at 1 and they work their way down to the bottom at 10. And then W, which is west, robot column, minus minus. So this just for simplicity or for testing purposes, console.log robot row, and we'll print out robot row, and then we'll do the same thing with the column. So now every time he moves, we'll see exactly what row he's supposedly in. So refresh, and when I move once, it says that he's in row 9, which is correct, 1, 2, 3, down to 9, and then column 1. Now he's in row 8, 7, 6, 5, 4, 3, 2, 1. Let's turn east. Now he's in row 1, and he's also in column 1, but now he's in column 2, column 3, column 4. So now we know where the robot is. Well, where the heck's the donut, right? How do we know which row and column it's in? Well, we don't. There's not a super simple, easy way to know with the way our code's written right now. But little teeny change to our code, and it'll be super easy. Right here in the build world function, what we're going to do is do a nested for loop. We'll do 10 iterations for the row and then 10 more for the column. It'll be very simple, right? So I'm just going to duplicate this, and this will be the row, so for R, and we'll do C for column, and then we'll change this to 10. So it's going to loop through 10, and each iteration of that, it's going to run this 10 times. And I got a typo there. And so what we'll end up with is still exactly the same grid that we have, but the difference is we'll be able to control and look at where the donut is, and I'll show you that part in a minute. But for the moment, what we're going to do is I'm going to comment out this line here, and I'm going to set it back to just the plus sign, because we're going to have to change this random business here in a second, and that's not going to work for the moment. But I just want to show you that the grid is still the same. Nothing changed. The robot still knows where it's at. We can turn. Nothing's changed. I still have 100 rows, but I did them 10 by 10. 10 rows, then 10 columns. So I did it with a nested for loop. But that gives us this advantage here. So rather than checking if r equals I, that's not going to work anymore. What we're going to do is make two random numbers that are between 1 and 10. And then we'll call one random row and one random column. And then in here, we're going to check to see if random row is equal to the row that we're on, and random column is equal to the column that we're on. And that will happen every single time, because this will always be some number from 1 to 10, and this will always be some number from 1 to 10. And every combination of that will exist. Row 1, column 1, row 1, column 2, row 1, column 3, and eventually all 100 versions of that will exist. And so somewhere along the way, there will be a match, right? So if we just put that whole thing in parentheses there. Now, everything should be the same, but now we can do something sneaky. Now, when I refresh, it should still be all the same, and this dude should be able to move, turn, move, and so forth. Okay, now, what we can do in our image, well, since we know when we created this, we know the value of the row and the column. So let's store it in the image. Data-row is equal to something, and data-column is equal to something. Well, what are the somethings? Well, we do our famous quote plus plus quote, quote plus plus quote, and the row is equal to R, and the column is equal to C. Well, now check this out. When we refresh, and I'm going to open this up, let's look at the donut. The donut is aware of where it is now. Data row 4, column 5, and that's true. 1, 2, 3, 4, and 1, 2, 3, 4, 5. So it knows where it is. Let's refresh it and look at it again. It should say row 1, 2, 3, 4, 5 in column 1. So let's take a peek. And row 5, column 1. Well, now all we have to do, when I move the robot and I click the eat button, what I want to do is check and see, okay, I know that the donut is on 5.1. Well, is the robot on 5.1 as well? And sure enough, it is. So we want our code to look for that. And if it is, then we'll eat the donut. Okay, so let's take a look at our eat function. Rather than doing eat the donut, let's take a peek here. So we need in our code here to compare the robot's position to the food's position, which means we need access to the food, which we don't have yet. So we're going to let food equal document.query selector. And if you remember, we put a class of food on it. And then we're going to access this food object in our eat function. However, we're actually going to get an error, right? So I'll prove that to you. If I just say console.log food, and we want to actually look at its attribute node value. This is actually going to give us an error, right? So let's run it. I'll show you what we're talking about here. So when I click eat, I get this here. Cannot read properties of null, reading attributes. Okay, why do we get that error? Well, because look at what's happening on line 5. The first thing that happens on line 5 is it's saying let food equal this donut that we've placed, except we haven't placed it yet. This happens before we initialize and build the world. So we can't do this until after we've built the world. Once the world's been built, then the donut exists, then we can target it, right? So we're going to use this in our initialize function, and we're just going to have another variable that we're going to start here called food. And then in our initialize game, after we build the world, after we initialize the robot, after we add the listeners, then we do that. Now this will work. Refresh, eat, and now it's printing this out, okay? And that's printing out the row, which is 10, which is where the donut is. Okay, well, all we got to do now really is compare this. We want to say if that row value is equal to the robot, this food's column value, right, is equal to robot column. Then we want to eat the food. So let's start with that. We'll just do our silly message again. Console.log, you ate it, right? And that will only work if we're on top of the donut, right? So if I refresh it, I click eat, nothing happens. But if I move, turn east, move, I click eat, nothing happens, but let's keep going. Click eat, Now it says I ate it. So now we're in the right place. All we're going to do, we're going to make the donut disappear, right? So we already have access to it. So we can just do food.style.display none, right? So let's start there. Refresh, and we turn to the east, move. You can see the donut sticking out there, but when I click eat, donut disappears, okay? Next up, I want to put the robot right in the center of the screen. And so that's going to be robot.style.top is, I think it's something like -500. Let's see what that does. And I'm actually going to take out this if condition for the moment so that I can just click eat whenever I want, right? So eat. And so that's not quite right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I want them like right in the middle. So that's going to be like 550. I think that's what I want. Yeah, that's pretty much dead center-ish on the rows. So let's do the same thing with the left. And I think it's like 400. Refresh, eat. So is that right? 1, 2, 3, 4 rows on each side. 1, 2, 3, 4, 4. Nope, we need to scooch them over 450. There we go, dead center. Okay, it looks a little off there, but that's close enough. Like, I don't want to get into like, 455 or whatever. And the reason, by the way, he's off, you'll recall, he's kind of not centered inside the box itself, right? We could fix that by putting a teeny padding left on all of the divs, but I'm not going to bother messing with that. Okay, so this is close enough to what I want, but I also want him to be ginormous, right? So I want to do robot.style.transform equals scale 5. So now when he eats, he's ginormous and he's right in the middle of the screen, right in your face. But I also want him to rotate, right? So I'm going to comment that transform out for just a minute, and I'm going to show you rotate. Now, if you do the math, 0 is pointing upward, is 0 degrees, but it's also 360 degrees. It's also 720 degrees, right? You just keep adding 360. And then, so I calculated rotate 1440 is still points you back to 0. That'll get him to spin a bunch of times, right? So if I refresh, and you see how he spun there? Now he didn't grow because I took that piece off. The problem is when dealing with transform, you can't do 2 of them like that. You can't even do that in your CSS, right? I can't say right here, transform scale 5 or 4, and then rotate, transform, rotate, right? You can't do that. I'm not going to bother typing all that, but you can't do that. You have to put them all on the same line. So it would have to be something like, and whatever the rotate degrees are. So it's the same thing that you do over here. And also we want to rotate on the Z-axis, just being specific. Whenever I'm doing more than one thing in the transform, I like to be extra specific. Rotate Z, like that. Let's check it out, refresh. I'm going to eat, and he rotated, and he centered himself, right? Now, I want to slow that down a little bit, so we're also going to robot.style.transition equals all, and we'll do like 800 milliseconds. And refresh, and there we go. Okay, so now let's turn this back on to where that only happens when he actually eats the donut. And so he's got to go all the way to the top of the screen, turn, move, and eat. And there we go. But now we got a really big problem.